In the last video, I wrote the test for the GildedRose refactoring exercise that looked a lot like Gherkin, the DSL of the behavior-driven development tool Cucumber, but it was actually just plain Kotlin code, using only Kotlin and JUnit features. And today, I want to refactor some code based on tests like that. I'm still using GildedRose, which is a refactoring exercise that's available in multiple languages. I'm still using Kotlin, and if you're interested, you can find it on Emily Bache's GitHub. My name is David Tanzer, and for the last almost 2 decades, I've been helping teams and companies to write better software and also to get better at writing software. I've done that as a developer, software architect, trainer, and technically agile coach. GildedRose is a refactoring exercise, and the setting takes place in a medieval inn or in a fantasy setting, and this inn sells items. And those items have a quality and a sell-in date, and as time passes, those values changes. There is some software that calculates how those values changes, but it's implemented in a way that's very hard to understand, with long if-else cascades, string comparison, unclear arithmetics, and so on. There is a description of the business rules, and that's actually not bad, but it's still somewhat unclear and somewhat ambiguous. The goal of this exercise is to refactor this update quality method that updates the quality and the sell-in date of all the items as one day passes. And also the constraint here is we are not allowed to change the interface of this class, and we are not allowed to change the item class. So there's basically 2 ways that we can approach this refactoring. The first way is to write comprehensive tests for this code for all the business rules, getting good test coverage here, and then to start to refactor. That's basically the easier strategy, because when we start to refactor, we already have all the tests in place, but it also is a strategy that requires quite a lot of effort up front. So it might not be feasible in a real legacy code setting to write all the tests we might need for refactoring. So what I want to try here is to do some gradual refactoring, right? So to write a minimum amount of tests that let me start to refactor, and then very carefully refactor the code, add more tests, do some careful refactoring, and so on. That's harder than the other strategy and not as safe, but I think I can do it in a reasonably safe way, and you can tell me afterwards if what I did here would be safe enough for you or not. There's another way to quickly get this code under test using approval tests. That's often possible even for real legacy code, and if you're interested in that, watch Emily Bache's video where she describes how she gets this code under test with a really good test coverage really quickly. To get started, I wrote only 2 tests, and they are for sulfurous, which is a magical item, and the special behavior of sulfurous is that its quality and its sell-in date never change. So you can see here that this code looks a little bit like Gherkin, but it's plain Kotlin code. If you're interested in how I wrote the test like that, and how I wrote a test automation layer to support me writing tests like that, watch my previous video on the topic. For now, we have 2 tests for sulfurous, and they are green. But as you can see here, they barely cover any code, any production code. So we really don't get a lot of test coverage from those 2 tests. So if you want to start to refactor with just those 2 tests, we have to be extra careful. But there's still 2 things for now that I feel confident enough to use. One is the refactoring tools of my IDE. So one rule of thumb for me is that if I use a refactoring tool of my IDE and it does not give me any warnings or errors, then I'm assuming that it worked correctly. And working correctly for a refactoring means that it does not introduce any new functionality, it does not remove functionality, but also that it does not introduce any new defects and it does not introduce any new bugs. So refactoring must be feature for feature and bug for bug compatible. And for all the tools of my IDE, I'm just assuming that this is the case. And then there is a list of provable refactorings available on GitHub. I'll link it in the video description below, where also those refactorings are provable in that they will never introduce new bugs, but also won't remove bugs, and the same for features. So if you use them correctly, they are also feature for feature and bug for bug compatible. And so I'm gonna use those very carefully. The first step I want to take here is a refactoring that my IDE provides. I want to extract a variable from this. So I can use introduce variable here, and I want to replace all the occurrences. And now I have an item that I can use later, and it's just a little bit more readable like that. Now, the next thing is so simple that it's not even on the list of provable refactorings. I can introduce an empty if. And I hope you can see that this does not change any functionality. It does not add or remove anything about the functionality. It might introduce slightly different timing, but we're not concerned about timing right now here. And also, since this if is empty, I can add a condition saying that if the item is sulfurous, do nothing. The tests are still green, and we wouldn't have expected anything else than that. So the next provable refactoring I can do here is whenever I see an if-else-if cascade that doesn't have an else block, I can add an empty else block without changing the functionality. So that's on the list of provable refactorings, and that's what I want to do here. The next refactoring is also a provable refactoring, and it says that if there's code after an if-else cascade, then I can move this code into all branches of the if-else cascade, and I still won't change any functionality. So that's the third thing I want to do here. And I'm just going to take all the code that's after the if-else cascade and paste it into the if block and into the else block. And just to remember what we did here, I'm going to add a comment here that this is the original code. The tests are still green, and what's important now is that I should never change any code here in the else block. So the original code stays untouched right until the end, where then hopefully everything is covered by tests and this code is not needed anymore. So there is no safe way to do any changes in here, but I can safely change the code in the then block, because here I know that it's sulfurous and I do have tests for sulfurous. So there's one more thing that I want to do before I commit for the first time, which is I want to move everything here into its own method. And I'm calling this update sulfurous. And of course, I do not want to also remove the duplicate, the original code, because the original code must stay as it is. Tests are still green, so I can commit my changes now. Okay, now update sulfurous has its own method and also has some comprehensive tests. So with the two tests here, we test all functional aspects of sulfurous that are important. And also the call to update sulfurous is covered by tests, so now I can refactor update sulfurous, and when I only touch code in here, then I'm actually protected by tests. So let's do some easy stuff first. Here, in update sulfurous, we know that the item name is sulfurous, so this code can never be executed here inside this if, so I can remove it. Then I can also remove the empty if, and again remove an empty if. Then here we have the same thing again. The name is definitely sulfurous, so this code can never be executed. I can remove it, and I can also remove the empty if. And here we have the same thing again. This code can never be executed. I can remove the empty if, and I can again remove the empty if. The if in this line says that the item name is not h3 and is not backstage passes. So we know that in the else block it's either h3 or backstage passes, so we can remove all the code in the else block. That too. Then we have an empty else block that we can remove. It's a provable refactoring, and we have an empty if that we can also remove. And here the if says if the item is not h3, so in the else block it must be h3. And this if says if the item is not backstage passes, so in the else block it must be backstage passes. Then I can remove an empty else, remove an empty if, remove an empty else, and remove both empty ifs. And the tests are still green. If you ever did a GildedRose cutter before, then you probably already knew that I would be able to remove all the code from update sulfurous, but I wanted to do it in a step-by-step way using provable refactorings like removing empty ifs or removing empty elses. So today I had 2 tests for sulfurous, which test sulfurous comprehensively, but nothing else. So the test coverage was very bad, but using only IDE refactoring tools and using provable refactorings carefully, I refactored the code so that the update sulfurous function is already pretty okay. I think this is clean enough for now. What do you think? Was that safe enough? Or would you have preferred to have more tests in place before? And if you're and if you think that we would have needed more tests before, then why would we have needed them? Please tell me in the comments of this video, and if you have any questions, suggestions, or anything else that you want to tell me, please also tell me in the comments or connect to me on Mastodon or Blue Sky. In the next video, I want to show you how I'll refactor H3 and backstage passes, which is slightly more complicated than sulfurous because we cannot remove just all the code. But on the other hand, I might probably move a little bit more quickly than today, not explaining all the provable refactorings and everything that I do. So, see you next time.